Hello everyone, today I'm going to be covering a new feature for our free spline mesh tool that now animates meshes along a spline. You can download this tool for free on Fab from this link highlighted here, which takes you to a Google Drive folder with the blueprint in it. We also have an option to pay for it on Fab just as a way to support our development efforts. Any money made from this allows us to work on more updates like this, and if you buy this on Fab, you'll have access to the demo map seen on our tutorial videos for this tool. Thank you to all those who've already supported us through these paid options. You all made it possible to fund this new update. Thank you. Today, we are covering spline animation. We now allow the option for meshes to be animated along the spline with quite a few different options. You can animate deformed and periodic meshes, although I highly recommend just animating periodically placed meshes. For anyone unfamiliar with my terminology, I will be referring to spline mesh components as deformable meshes because they deform along the spline, and I will refer to static mesh components as periodically placed meshes just because that's how I have it defined in this tool. The reason I recommend mainly animating periodically placed meshes is that deformed meshes have to calculate how to deform the mesh along a spline, which is just a series of vector math operations for each vertex in the mesh. This means the more vertices that exist on the spline meshes will equate to longer calculation times, which in turn can be loss of performance. So something as simple as UE5's default box won't have much of an effect, but a series of meshes with just even a moderate number of vertices can be noticeable. And again, periodically placed meshes doesn't really have this problem, so use meshes with as many vertices as you want for that. Now, there are 4 different types of periodically placed meshes, all of which can be animated. Static meshes, instant static meshes, or as they're commonly known, ISMs, hierarchical instant static meshes, also known as HISMs, and lastly, spawned actors. By default, you have static mesh components being used. You can change them to be ISMs or HISMs by scrolling down here to the periodic placement tab and checking these options. Now, they can't be both ISM and HISM, but they offer similar benefits. In yesterday's video, I explained the difference between all these types and when to use them. It will be linked in the description, and a little banner might show up in the top right corner of your screens with the link to it. At this point, I'll assume you know the difference and when to use them. So I'm going to cover some notes and restrictions for using ISMs and HISMs specifically for this tool. For one, ISMs and HISMs can't do negative scales. Static meshes can be inverted by applying a negative scale, but ISMs and HISMs cannot. They also can't be used for movement like a static mesh can. This is because ISMs and HISMs have no physics logic. This means the actor is never expected to move or be moved by something. That includes gravity, player interaction, and other external forces. It is allowed to be animated because you are allowed to adjust the instance's location at runtime, but it's just practically teleporting beneath your feet and not actually moving. This is why the character doesn't move despite standing on the animated meshes. Could you code a way to attach the actor to the instance? Probably. But I would really just recommend using the regular static mesh components by not having any instancing selected or to use blueprints. The physics actually works really well this way. You can use this as a conveyor belt, elevator, escalator, or a wall to push the player, but the wall pushing comes with a caveat that I'll talk about in tomorrow's video. This physics system works so well, I may even try adapting this blueprint to make specialized blueprints with those purposes, and post them to Fab, but we'll see. In the near future, I really need to get back to developing my road system updates for the dynamic road system on Fab. Now that we covered ISMs and HISMs, let's talk about how to animate spawnable actors and blueprints along the spline. I have a spline here that has 2 different meshes in the spline meshes array, a cube and a sphere. We are going to replace the sphere with this very simple BP sphere blueprint, which will just destroy itself when collected and give a little debug message. You can think of this being an item box in Mario Kart, Rings in Sonic, or any other collectible that spawns along a path. So since we are only replacing the sphere mesh, which is mesh 1, as seen by the index it occupies in the spline meshes array, we can create a new entry in the override mesh with BP variable, and set the mesh ID to 1 and the actor being our blueprint. This change will not be enacted until you press spawn objects. Once the objects are spawned, the blueprint will no longer change anything about the spawned objects, other than the animation. If you need to change something, destroy the objects, make your changes, and spawn in your objects again. Now, we're ready to animate them. We press play, and we see that they are moving along the spline. We have a sphere in front of us, and when we walk into it, It disappears and gives a debug message. Very good. We can also stand on these spawned actors and be moved similar to static mesh components. Now let's cover the more universal options for the animation tab. The first option is not really animation, but simulate gravity and physics will move the mesh by making it affected by gravity and other physics. This can be useful if you need to disperse items or blueprints along a path, and have that extra layer of interaction with the player. We also teased a rockfall demo in the last video, and I wanted to share some of the background that made that possible. I use these settings in the blueprint, everything else is default. To vary the locations of the meshes, I use the randomize transform button, and randomized it between the lower and upper limits we specified. There's a new variable called report ending positions in the advanced menu dropdown, and what it allows you to do is output all the positions of the meshes after simulating physics in your level. It outputs all that information into your log, but you'll need to copy the text from an external editor because UE5 adds spaces between lines in their logs, which breaks the format we need. From Notepad, I'm going to find the message with all the transforms and copy it. Then we bring it into UE5 and paste it into the randomized data variable. It should then have all the meshes placed where they were when the simulation ended. If not, you may need to disable ground snapping and/or revert mesh transform to default. This new method is a good alternative to the previous randomized method, especially when you don't want your meshes to overlap. Now, onto the real animation options. We can enable animations along the spline by using the appropriately named variable animate meshes along spline, and by having auto start animation enabled, it will automatically begin playing the animation as soon as the level is started. So, we can see that it's animated quite nicely. But let's make it go faster. I have this animation set to complete in 5 seconds. To make it go twice as fast, we need to set the animation duration to 2.5 seconds. We press play, and it's faster. If we want it to be reversed, we set the speed to negative. We also have 2 different ways of looping for this animation. We can loop the actual animation, and loop the meshes in the animation. Starting with the option of looping the meshes, we can see as the meshes go off the end of the spline, they come back at the start of the spline. This is easier to see when having a closed loop how continuous this process is. Meanwhile, looping the animation will allow it to play over and over again with whatever settings you had it to start with. We briefly talked about the variable auto start animation, but what happens when we don't want to start the animation automatically and we want it to be triggered by an event? I have an example in the demo level that does just that with animation and the option of gravity and physics. All this is done by using a trigger box in the level and referencing it in the level blueprint. So let's open that up. We have 2 events for our 2 trigger boxes, the one that starts the animation and the one that enables gravity and physics. In order to do this, you just need your trigger box selected in the level and choose the event type you want it to trigger. For this example, let's choose when the overlap stops. Now, we are going to take our blueprint reference from the scene and drop it in the level blueprint and call stop animation. We can pull up the animation options by typing call animation. Notice for the animation we can call start, stop, and resume. Starting animation will always start the animation from its beginning position, meanwhile resuming will allow the animation to start at whatever position it's in, which is helpful if you are stopping and resuming your animation. If you ever want to reverse the animation from here, just set the time to be negative before calling start or resume. So now let's test this. It starts by being turned off, and then we walk in, and it starts the animation. And we walk out, and it's off. Perfect. I also set up the same system that toggles physics instead. Another thing you can do is reverse the logic, so it only stops when you're in the volume. I probably should have had the auto start variable on, so we have to walk out of the volume for the animation to start. A nice thing about this reverse logic is that the physics from the animation will carry over if we step into the physics volume. As you can probably tell, calling the enable physics function will immediately turn off the animation, and calling the start animation function will immediately stop the physics. So there's a lot of cool things you can do here. The last feature is custom timing curves, and what this allows you to do is specify the positions along the spline at certain time frames. I can create a custom curve and change it to be on a scale from 0 seconds to 1 second, and then let's make a curve that starts really fast and then slowly returns to its beginning position. Let's insert it into our blueprint and press play, and sure enough, it's going at the speed we set it at. I also want to note that if no curve is specified, it just uses a linear time curve. So we have this animation system, but it begs the question, why not just use Sequencer? Sequencer is meant for animation, we can move things along a path just like in this. So let's cover when to use this new system, when to use Sequencer instead, and when it's better to actually use both. Let's start with the benefits of this system over Sequencer. This system supports ISMs and HISMs, which cannot be easily animated through Sequencer. This system also supports hundreds if not thousands of instances without any problems, which would be burdensome to scroll through and set up through Sequencer. It's also very simple to set up for multiplayer animation since it can be a replicated system. And lastly, the spline is changeable at runtime, so it's more dynamic. Now, you shouldn't use this system alone if you are planning cinematics that involve camera cuts and very specific timings, because the timeline being used in this blueprint will not match the timing of Sequencer. We would need a new way of syncing it up so that each frame is tied to an update to the blueprint, which is why we have the animation override time exposed for Sequencer. This timeline override variable only affects the meshes on the spline when the game or simulation is actually playing. It does nothing in editor for the time being. Let me go through the steps for using this with Sequencer. We got a level sequence, and we just need to add the BP spline mesh as a tracked actor. Then we're going to track the timeline offset override. This progresses your animation on a scale from 0 to 1. So we'll start the animation at 0 and end it at 1. Then we needed to update the blueprint, so we need to track it as a repeated event. In this repeated event, it will show green, and it will be an empty event. We can double-click the green area to open up the director blueprint. And the next part is very simple. We have the reference to the blueprint, so we're going to call the function override animation offset. We also need to feed in the value we are animating, but we already updated it in the blueprint, so we can just have it refer to its own value. And in just 3 nodes, we're set up. We can add the sequence to the level and have it autoplay and repeat. To verify, we just start the level, and we see that it's working. That is how you combine the precision of Sequencer and the flexibility of this blueprint. Now you know how to animate meshes along a spline, but you may run into some very specific problems, which is why tomorrow's video will be covering issues related to blurry meshes, uneven timing along splines, teleporting, and camera jitter from being pushed by animated meshes. Thanks for watching. The blueprint is free to download, and if you like it, it would mean a lot if you could spend $5 to support more projects like this in the future. You could also follow us here on YouTube or on Discord for more news on this tool and more to come. Until next time.